Greetings and welcome to GILFORD'S lectures. So today we are going to be looking at a question taken from the course Electrostatics and Electrokinetics, which is studied in the Higher Technical Teachers Training College of the University of Bamenda. So the question goes thus: consider the circuit diagram of the figure 1 and the following values. This is the figure 1 and these are their values given from A to J. Using Kirchhoff voltage law and Kirchhoff current law, which of the following values represents the value of the current flowing through the 2, the 14, the 32, the 11 and the 3 ohm resistors? Okay, now to solve this question, you need the background knowledge on Kirchhoff voltage law and mesh analysis. Alright, the review on Kirchhoff voltage law. So Kirchhoff voltage law states that the algebraic sum of all the voltages around a closed path is 0. Mathematically, it is written thus and read as the sum of all the voltages, okay? The sum of all the voltages from the very first voltage to the last voltage in a closed loop is equal to 0. So to illustrate Kirchhoff voltage law, consider the circuit below. Okay, the sign of each voltage is the polarity of the terminal encountered first as you travel around the loop. So you could travel either in the clockwise direction or the counterclockwise direction. In this case, I choose to travel in the clockwise direction. So follow it up with me. Now, if you are traveling in a clockwise direction, remember the sign of each potential difference is the polarity of the terminal encountered first. I've circled the terminals encountered first, okay? So the sign here should be what? A negative, the sign here should be a positive, the sign here should be a positive, the sign here should be a negative, and the sign here should be what? A positive. So when you do that, you sum all the voltages and their respective signs as I have put them, okay? When you do that, you obtain this equation equal to what? 0. Remember our statement, the sum of all what? The voltages from the very first voltage to the last voltage is equal to 0. So this is it. Alright, when you rearrange, you obtain this. Actually, this represents what? All the voltage drops in a circuit, and this represents the voltage rise. So let me show you how you can know if across a particular element you have a voltage drop or a voltage rise. So if you already know the sign of the polarities across the terminals of an element, if current moves from what? The negative to the positive terminal, you have what? A voltage rise, okay? So here you have a voltage rise, here you also have what? A voltage rise. But your current moves from the positive to the negative terminal, you have a voltage drop. So here we have what? A voltage drop, and here we also have a voltage drop, okay? So let's now look at mesh analysis. So the mesh analysis method. Mesh analysis provides another general procedure for analyzing circuits using mesh currents as circuit variables. Using mesh currents instead of element currents as circuit variables is convenient and reduces the number of simultaneous equations to be solved. Recall that a loop is a closed path with no node passed more than once, while a mesh is a loop that does not contain any other loop within it. I will show you that as we start to solve a concrete example. It's important for you to know that the steps involved in to determine mesh currents are: first of all, you need to assign mesh current to the n meshes you have identified in a particular circuit. You need to apply Kirchhoff voltage law to each of the n meshes, and you need to solve the resulting simultaneous equations for the mesh current. So these first steps will require you to first of all look at your circuit critically, identify the loops, and say if that loop is a mesh. It's important for you to know that all meshes are loops, but not all loops are necessarily meshes, since a mesh is a loop that does not contain any other loop within it. I will show you that as we look at our example on mesh analysis. So now imagine you have a circuit like this one below, okay? It's clear that you have what? 2 loops. This type of circuits are easily solved using a special method known as mesh analysis method. It helps reduce the number of equations to be solved simultaneously. Let me show you how you apply mesh analysis method. First of all, you have looked at your circuit, you have identified how many loops. If you said 3, you are very correct. But the number of meshes are what? Just 2. So this is your first mesh, this is your second mesh, which are actually loops, and there is what? An outer loop, okay? There's an outer loop. But this outer loop contains 2 other loops within it, so it is not a mesh, so you cancel that loop. Okay, you need to write an equation defining the mesh containing the current I1 and the mesh containing the current I2. So you need to define an equation for the meshes containing the current I1 and I2. For you to write that equation, you draw your loops in a clockwise direction. Here the polarity made first is negative, so you assign a negative V1 here. So you have a negative V1, and you add all the other potential differences in a special way, considering what? Your merge current. So here you don't write this capital I1. You don't find the potential difference across R1 by multiplying it to capital I1, because you want to find an equation in terms of the mesh current little I1. Now this resistor is shared by the meshes containing the current I1 and I2. So his equation is written in a special way, because if you are writing the equation containing the current I1, that is for mesh I1, you consider I1 to be your driving current, while this other one is opposing. Okay, so the potential difference across the resistor R3 will be R3 into I1, which is your driving current, minus I2. Okay, alright, so this is your first equation, and the second equation will be written as you go like this. The polarity made first is positive, so here you have a positive, so you write positive V2 plus R3. Now your driving current is I2 minus I1, you close your bracket, plus what? The potential difference across R2, which will be R2 I2. When you do that, you are going to obtain the following equations. Okay, let me take it again. If you first of all, for you to determine the mesh current, you need to assign mesh current to n meshes. Before assigning mesh current to n meshes, you need to identify the loops and tell if the loop is a mesh or not. From there, you apply Kirchhoff voltage law to each of the n meshes. Okay, and you solve the resulting equations. So here, if you were given the values of the resistance and the PDs V1 and V2, you can use it to solve these equations. Okay, remember that if you have one mesh, then you have one simultaneous equation. If you have two meshes, then you obtain two simultaneous equations. Okay, so I believe you have understood it quite okay. I urge you to like the video, share to your friends, subscribe, comment, ask any questions if you have any. Okay, thanks in advance, and watch the next video to see how the question proper was solved. So this is the question proper, so you just like, comment, so that you get notified when I send the solution, the explained video for the next.